In this section, we've seen several ways that variables might be declared: private, shared, reduction variables, and non-privatizable variables that are read-write conflicting and therefore need to be controlled by synchronization. What kind of variables should be declared private? Well, obviously, privatizable variables. What kind of variables should be declared shared? There are two kinds of variables that can be shared: read-only variables and read-write non-conflicting variables. Now, I did say earlier that read-only variables could be copied to various memories if memory is not uniformly accessible and it's quicker to access some memories from some processors as well as others. But read-only variables can also be treated as shared. What kind of variables should be declared reduction? That's so simple it's almost a trick question. Reduction variables, of course. And what kind of variables then should be non-privatizable and read-write conflicting? So they need to be shared and they're read-write conflicting. Well, these are variables that should be declared as shared also, but they should be protected by synchronization. The categorization we have here is a little bit different from the categorization we saw earlier. Earlier we saw read-only, read-write conflicting, and read-write non-conflicting, and now we're seeing shared and private. So why do we have these different categories? The first set of categories we had, read-only, read-write non-conflicting, read-write conflicting, determines how the variables are used. The second set, that is to say private, shared, reduction, and non-privatizable, determines how they are declared. You use the classification in the first set, that is to say read-only, read-write, conflicting or non-conflicting, to determine how to declare the variables in the second set. Three classes of variables, read-only, read-write non-conflicting, and read-write conflicting, are declared as shared, but only read-write conflicting, the ones over here, need to be protected by locks. Well, let's take a look at our examples again from Lecture 10b. Example 1 had this two-statement doubly nested loop, and we decided that the read-only variables were n, c, and d, the read-write non-conflicting variables were a and b, and the read-write conflicting variables were I and j. Then which variables should be declared as shared, and which should be declared as private? Well, we've seen that variables in the first two categories, read-only and read-write non-conflicting, can be declared as shared, and the other variables can be declared as private. In example 2, we have three statements inside the doubly nested loop, and the parallel tasks are the 4j iterations. We saw there that the read-only variables were n, I, c, and d, the non-conflicting variables were a, b, and e, and the read-write conflicting variable was j. Then which should be declared as shared, and which should be declared as private? Well, again, the ones in the first two categories should be declared as shared, and the one in the third category, read-write conflict, should be declared as private. Now let's take a third example. This is a simple program for matrix multiplication. Note the triply nested loop. The inner loop takes care of forming the dot product of a row of A and a column of B to form an element of the result matrix. First of all, suppose that the parallel tasks are the 4k iterations, the tasks in the innermost loop. Determine which variables are conflicting, which should be declared as private, and which need to be protected against concurrent access by using a critical section. In this situation, I and j, the indexes of the outer loops, are not changed by the inner loop, and so therefore they're read-only as far as the inner loop is concerned. Ditto for the source matrices A and B. They're not changed by the code at all, so they too are read-only. And then the loop limit, n, is not changed during this code segment, so it's also a read-only variable. That gives us 5 read-only variables altogether, A, B, I, j, and n. How about read-write non-conflicting variables? What variables are read-write here? There's only two of them. First of all, there's the index of the innermost loop, k. But clearly, that's a conflicting read-write variable because different tasks have to modify the k. Every task at the end adds 1 to k to get the next value, and therefore it's a read-write conflicting variable. And ditto for c. c is a read-write conflicting variable too, because different tasks operate on C sub ij. The different tasks within the innermost loop, and remember each iteration of the innermost loop is a separate task, all modify the same C sub ij element. So C and K are our read-write conflicting variables. Now which variables should be declared as shared and which should be declared as private? The shared variables include the read-only variables, the read-write non-conflicting variables, and any read-write conflicting variable that needs to be protected by a critical section. In this situation, it's clear that C sub ij, that the C matrix, needs to be protected by a critical section because the different K tasks are all trying to add to the value of C sub ij, and they've got to do so in a disciplined one-at-a-time fashion. So that means that in addition to the read-only variables, C needs to be declared as shared. And then which variables need to be declared as private? Well, there's only one variable, K, and it is declared as private. Which variables now need to be protected by a critical section? I think I've already said that. It's C, because different tasks read and write C concurrently, C sub ij concurrently. Different 4K tasks read and write C sub ij concurrently. Well, now my question to you is, suppose the parallel tasks are the 4i iterations. Determine which variables are conflicting and which should be declared as private, and which need to be protected against concurrent access by using a critical section. I'm going to ask you to answer the 6 questions in the tableau. Fill in the 5 boxes, and then answer which variables need to be protected by a critical section. In order to keep the answers manageable, I'd like you to use the same case as the program uses. That is, A, B, and C are capital letters for the arrays. All the other variables should be listed in lowercase. And please list the variables in alphabetical order. Either you can put a space between them or not a space between them, but please be consistent. If you put a space between 2 variables, put a space before the 3rd variable as well. And that will make it easier for me to have the auto-graded. If for some reason one of the answers to one of these questions is none, just write NONE in lowercase. Thank you.